Wonderful. Hello, nice to meet you. Um, we represent a company that emerged out of technology out of Boston, Massachusetts. And really, the company fundamentals are the people, the process, and the product. We're really a great group of Harvard professionals, MIT professionals, and we have a product that's very unique. In the diagnostics field, fluorescent reagents are commonly used. They actually mandatory. They must be used for diagnostics of blood pathology, biopsy, and all the rest. We've been mentored by three leading cancer institutes, of course, Dana-Farber in Boston, Cedars-Sinai, and of course, Roswell Park. The fluorescent reagents are mandatory for flow cytometry, DNA assay, um, microscopy, fluorescence microscopy. And the whole massive market, a $20 billion market for these, is dominated by five players. Two of the players are very, very antiquated. So when we began our mission back in 2012 to develop this nanoparticle, we simply asked the cancer institutes, what is it they're looking for in an advanced product? What does the next generation product represent? And essentially, they made a list. They made a list of about 20 things, highly technical things relating to biomolecular diagnostics. So we set out developing this product. We have a fully issued patent on it. We have additional patents pending. And we address all of the 20 requirements. Most recently, our final stage of development involves the attachment of a protein or an antibody to the fluorescent reagent. And that's almost done. We're about probably 75% there. We anticipate in the next 6 months that we'll have a finished product. And the product business model is rather simple. First off, we're a group of people that have a lot of experience, myself and the other team members. We're not a bunch of kids coming out of the lab. The product introduction in the monetization of the IP is essentially prototype the product, pitch it to industry, and then exit. We're going to exit license sale. And why you would ask why we would do this and how we would do this. So if you look at other successful companies, the Alexa Floor, Molecular Probes, or even Serogen, they were all acquired. They were small companies started at various universities, and either BD Bioscience or Thermo Fisher and Vitrogen simply acquired the company. So once you have a working prototype and you've proved acceptance in the marketplace, got the opinions of the thought leaders, of course we designed this for the thought leaders, you'll be quickly acquired. In the case of Serogen, that was a quick acquisition of $65 million. Molecular Probes was $350 million. We think we're going to be higher because our fluorescent reagent has multiple verticals. It can be used for many, many different things, including medical drug delivery and others. We recently had some discoveries with dealing with brain cells, breast cancer cells, and for a lot of different opportunities, multiple verticals. Quantum dots themselves are actually very much in demand across the world. We're non-toxic, and so we make our products out of a non-toxic material, whereas others are made from cadmium. Let me shut the stupid phone off. And so we have a non-toxic product that has great properties, and everybody is working with quantum dots across the world. They're doing everything from photovoltaic work, smart windows, battery efficiency, and of course the new optical thin film that's out in the televisions. We took a life science track, and we find that there are so many life science opportunities for this product that it's really a lifetime of opportunity. So that's basically a quick summary. I could give you data, tell you more about the people if you like, but I welcome your questions.
Okay, Mariana.
Oh,
Can't hear you.
yeah. Really? Okay. Can you hear me now?
I can hear you perfectly.
Thank you. First of all, thank you for being here and thank you for presenting the company. I think you've done it beautifully, and I appreciate your time and willingness to talk to me, to us.
Good.
Um, Several questions. First of all, from technical standpoint, I just looked up your IP, and it was issued. It was issued, but the priority date is 2005.
Hmm.
And your IP portfolio consists of 2 patents. One of them is will be expired in 5 years, right?
Right, right. We've expanded
Good
on
job.
our IP considerably. So that is what they call a process patent that we acquired from the State University Research Foundation of New York. And we've made considerable changes. Essentially, when we started, we were handed a bunch of pieces of paper and low production capability. Originally, we were able to make 20 mil of material, and we scaled it to batch reproducible, and also to quality issues. Let me tell you a little bit about quantum dots. Quantum dots are kind of like a golf ball. There's a center, there's an electron core in the center, and then there's various coatings. What's very proprietary about what we do and where our additional IP is coming is these coatings. They prevent ultraviolet degradation and oxidation, but also that surface chemistry is very, very important for the attachment of proteins. And we have some additional patents in that regard. Quantum dots have been around for a long time. They were discovered at Bell Labs over 30 years ago. And the only commercialization of them, everybody was very excited about them. The only commercialization really has been for the optical thin film and the Q dot, which is carried over at Thermo Fisher. Thermo Fisher's product is made from cadmium, so it's a heavy metal. We're very excited that we've stuck to the principles of green chemistry and also the restriction of hazardous substances directive out of the EU. We work with universities all over the world. Tel Aviv is one, all over the United States. And toxicity is a key issue for what we're doing. So back to the IP, we have great opportunity to expand the IP. We're kind of saving it right now. I'm going to be honest with you. We're going to pop up and surprise the competition. We're not advertising. Our website doesn't say much. And my experience with new product introduction worldwide has been that simply, don't talk too much and surprise the competition. So that's kind of our strategy.
I think it's a great approach.
Well, thank you for saying that.
And over deliver.
Yeah, absolutely. You come up behind the enemy lines and, you surprise them. You've got
Absolutely.
You got to watch out for Thermo Fisher, with the Q dot. I think Thermo's going to acquire us for a lot of reasons, and I could demonstrate those. So if you look at one of their particular products, the streptavidin conjugate, and I don't want to get too technical with you, but in the field, and I'm not a scientist.
By all means, go ahead.
Okay, thank you. In the field of conjugates, the value of a fluorophore is the ability to attach it to an antibody that drags it over to a disease and a disease marker in blood. So streptavidin is a very unique biotinylated antibody that binds to everything that's biotinylated. So the streptavidin conjugate is a great product. So if you compare it directly to the product they have over at Thermo Fisher, they only can make it in certain colors. They only have 6 or 8 colors that they have. We have 15 products, 15 colors right now. And that's a really big deal because you can multiplex with what you're doing in addition to the properties, in addition to the cell toxicity. The studies that we just completed on the blood-brain barrier and brain cell, you don't want to introduce toxicity to a cell. Cytotoxicity is a major issue. So there's a clear-cut advantage. But our biggest advantage is that we don't have any fluorescence decay. So a good example of that is all these other fluorophores that are on the market. We have an expression, they're bright until they aren't. Essentially a decay in brightness. We don't. We are bright for 10 years. I mean, you could make a television optical thin film out of quantum dots, and they're doing that. So that's a key advantage for cell studies, and not only that, for the clinician or the researcher. A good example is if you're in a lab, you're in a dark room essentially doing blood pathology, if you've ever been to a blood lab. So you're in the blood lab, and if you're exposed to any kind of light, there's a degradation of that material, whereas it doesn't. Secondly, we have a very narrow symmetric signature. It's a bright, steady, no fluorescence intensity signature. So it makes device reading really a lot easier for the operator, the clinician. I mean, I could go on. There's 20 advanced properties here, and they're separated the signals. So you could do a test, DNA assay as an example, that would be distinct and separate from all the other readings you're getting, which is very exciting.
And this is the point that you talked about, that signal does not decay, is a major advantage, because I have worked with those stains, fluorescent stains, and time frames are almost impossible to manage, especially when the experiment is large and it's going on for 24 hours. And that would be saver for any lab, whether it's medical or scientific.
Very stable. It doesn't have to be refrigerated. You know, you have all these different properties, and I can go through the whole list of properties. Of course, we're very familiar. So the way we started on this, and you have to understand it, is we started with the customer. We started with the Cancer Institute at Dana-Farber. And John Daly just simply laid it out to us. Dan, look, if you're going to break into this market, you need 20. Here's the problems in the business. You need 20 of these different properties and characteristics that will make them a winner. And the size is another factor too. You know, we're 2 to 5 nanometers. We control the size. And if you know anything about quantum dots, other quantum dots, a lot of quantum dots on the market, but they're not good for life science because there's size disparity. They make them one day, they're 2, 5, 10, 20. The Q dot is 20 nanometers, up to 30 nanometers with a conjugate. And they're not, well, good to use. We don't get our color from size. Our color, you know, so we have a fixed size, 2 nanometer 5, we can dial it in, and we get our color from the use of a metal doping ion. So that adds the stability and protects the intensity and everything else. And we have batch-to-batch reproducibility. So if you looked at the patents, if the patents are entitled template-assisted patent, that means it's a microemulsion template, a system of making these batch-to-batch reproducible. That's a really big deal. No other quantum dot manufacturer can do that. Good example is when they're doing the MIT, the Buendia process, that's a hot process, and they've got a volcano of chemicals going, and hopefully if they shut it off at the right time, they get a quantum dot, and it's the color they want. That's not the way we make these. You know, in a microemulsion template, it's at room temperature. There are various stages. There's longevity to it, and it's very, very specific. It's a big deal in my mind.
It is definitely, and the fact that you have been able to conquer it is amazing. Absolutely.
Thank you. It's a pleasure to talk to you because most people don't, you know, understand. It's very hard to pitch this because, you know, it's chemical engineering and biomolecular diagnostics. And on top of it, there are so many different layers to these dots. You've got the core, the electron core, the metal doping ions. This is at nanoscale, protective shells, surface functionalizations. Now we're working on the appropriate ligand length to attach a conjugate to it. We think, in any chemist will tell you.
Okay, and that's the next question, technical question that I was aiming for. Dyes in large are amazing, and they're amazing visualization tool, but they need to be attached to antibodies and other biological species to become diagnostic tool that we are all inspired to get. So where do you stand on this?
Yeah, so the most common surface functionalization chemical is carboxylic acid, COOH. But we make quantum dots in 5 different surface coatings: hydrazide, azide, carboxylic acid, CH3. So in addition to the 15 products, can I share a screen with you to show you the product line?
Absolutely.
Okay, and I think there's a button here somewhere. There we go.
Yeah, actually you can.
Okay, and do you see this?
Yeah. Give me just like 1 moment. Yeah.
So you can ask yourself, you know, what have we done for the past, you know, number of years? Well, developing this on, by the way, I'm the single largest investor in the company, but we did this in $2 million, which is remarkable. We protected the shareholders, and we came very far. So you can see here, can you see my pointer?
Yes.
Yeah, okay. So you'll see there's 15 products, and these colors are colors that nobody else does. That's a really big deal, okay? And the excitation source, this is the biggest thing I can tell you, is that these are one laser excited. So every other fluorophore has to have multiple layers of excitation. Our entire product line is either excited by the 355, or the 405, the 390 laser. That is huge, one laser excitation. The emission is very stable. The QI is good. These are great statistics. But look at the sizes. 3 nanometers? Oh my God, it's incredible. We can dial them. We can make them 5.
We meant to get the emission signal and separate between those?
No, so the excitation is by a 355. See all the excitations you could use, but one excitation at 355 lights up the whole product line. It's one laser excited. That is huge, huge. You know, the biggest expense for flow cytometry and microscopy are the multi-laser systems. They're $30,000 to $50,000 each. So you could now go to these portable flow cytometry systems with one laser with this product. That's a big deal. It's huge. It's the future. So going on, you know, we have the surface ready with amine, carboxylic acid, PEG, hydrazide, all these here. So if you really look at what we have, quite frankly, we have what the conjugation people want. The biggest dilemma that we have, can you see me back? Oh no, I think I'll shut that off. Let me see here. All right, I'm back. Did we lose somebody? Can't hear you. I think we lost someone. Mariana?
Maybe because Mariana, she's reconnect because of, like I say, today they have a problem with Wi-Fi.
No problem. Go wait.
Yeah, and she can like reconnect because sometimes it's like the problem with network.
Does she want to dial in?
Yeah, actually, yeah.
Can she dial into this?
Yes.
Well, she knows the topic. I'm very excited to talk to someone who understands this.
Sorry, Daniel. Yeah, it's looked like they welcome you to the new world.
It's tough stuff.
Yeah, because sometimes it's not like the Zoom, but the main problem it's like the Wi-Fi connection. It was same before. Yeah.
We can use a teleconference number if you prefer.
Yeah, actually. It was like the same for me.
Do you want to use a dial-in number? I could give you one with.
Yeah, actually, look, guys, they can move this conversation to the private side, and yeah, they can talk together without the Zoom or without the stream. What do you think?
Fine with me.
Yeah.